Hello everyone, welcome to Helm of Science. Your joint entrance main examination has taken place on the 20th of July. In today's video, we shall be doing the questions that have appeared in the second shift of the examination owing to the subject chemistry, right? And in today's video, I won't be discussing all the questions because it's not possible. So I have sorted down certain questions from the physical and inorganic portion, and the organic chemistry solutions will be coming up in the upcoming videos. So without doing any more delay, let's just quickly get into the questions. The first question, difference in the number of unpaired electrons in NiCl2 and NiCN6 2- is. So the first thing first, we have to find out the charge on nickel chloride as well as hexacyano nickelate ion, right? So how can we do that? For NiCl2, chlorine ligand has a charge of -1, so total of -2. The whole compound to be neutral, nickel has a charge of 2, right? So +2. So nickel +2 would mean argon core 3d8. Okay. Now coming to NiCN6, and it was 2-. So cyanide has a charge of -1, so this is -6. In order to have a -2 charge, what would be the charge on nickel? It would be +4, right? So nickel +4 would mean argon core 3d6. Another thing, this is a strong field ligand, right? So strong field ligand means there will be pairing of electrons. Another thing to be noted, this is a hexa compound, so this is an octahedral complex, right? So I'm not drawing the entire structure for octahedral complex, I'm just showing the splitting part. So what happens? The T2G orbitals, that is the dxy, dyz and the dxz orbitals are below, and the dx square minus y square and dz square orbitals are above, right? So first, and this is Ni4 plus d6. So there will be pairing of electrons. So if there is pairing of electrons, then the number of unpaired electrons would be 0. And for NiCl2, this should be number of unpaired electrons would be. Now since this is not tetrahedral or octahedral, any of the species, so we'll just do it according to our BBT diagram. So if this is the 3D representation containing 5 orbitals, so this would be 1, 2, 3, 4, 5, 6, 7 and 8. So number of unpaired electrons is 2. So your answer would be 2 for NiCl2 and 0 for NiCN6 2-. Moving to the next question. The next question says magnetic moment of an octahedral complex of Fe2 plus which has strong field ligand is. So question says the complex is Fe2 plus complex. Fe2 plus means argon core 3d6, and the question says it should have a strong field ligand. Strong field, as discussed before, there should be pairing of electrons then. And it also says that it's an octahedral complex. So again the same splitting, T2G below, EG above, and strong field including pairing of electrons. So it should be 1, 2, 3, 4, 5 and 6. So the magnetic moment is determined by the formula root over of n into n plus 2, core magneton, right? N is the number of unpaired electrons. In this case, number of unpaired electrons is 0. So your magnetic moment will be 0 in this case. The next question says, a radioactive substance becomes 1/16 of initial amount in 80 minutes. Find the half-life. So first things first, whenever you are said that it is a radioactivity containing reaction, That means they are hinting on you to use the first order reactions. Why? Because first order reactions do not complete. That is, their completion time is infinity. Similarly, for radioactivity also the completion time is infinity. That is why whenever radioactivity is mentioned to you, you should be using the first order reaction. So what does the first order reaction say? Rate constant is equal to 2.303 by time log of initial concentration by remaining concentration. Right? Now it is said that the initial concentration becomes 1 by 16 time. Right? In 80 minutes. So this should be 2.303 by t, 80 minutes, log of initial. If it is suppose A0, then the final remaining is 1 by 16th of A0. Okay. Now, then this should be 2.303 by 80 log of 16. 16 means what? 2 to the power 4. Correct? Now, we can write it as what? K is equal to 2.303 by 80 into 4 log 2. This is 20 times. Keep it that way. Then log 2 would be having a value of 0.30. Just simplifying the calculations, because since calculator is not allowed in the exam, so you have to do it as simply as possible. Correct? Now this 2.303 can be kept as 2 itself. If I just neglect this part, then this should be 10 times roughly. Make sure that it's all average. Alright, this is nothing 100% calculation, it's all average to make our calculation simpler. 0.30 divided by 10 would be 0.030 minute inverse. Now T half for a first order reaction is 0.693 by K. Yes, so 0.693 by 0.030. 0.030. Right? So one thing, this should come out to be, after calculation, 23.1 minutes. Roughly like that. Okay? So this should be your one answer. The next question says that the hybridization of nitrogen in NO2 minus, NO2 plus and NH4 plus are. Okay? So let's just do the question. NO2 minus, right? So what should be the hybridization? It should be central atom has 5 valence electrons plus 2 into 2 oxygen, each having 1 sigma and 1 pi. So for sigma it is plus 1 and for pi it is minus 1 plus 1 negatively charged electron. So this should be 6, which is a planar structure. So the trigonal planar. So the hybridization would be sp2. NO2 plus, same process, 5 plus 2 into 1 minus 1, but there is a positive charge, so this should be minus 1. This should be 4. Linear structure, sp, hybridized. And the last one was NH4 plus, right? So NH4 plus meaning 5 valence electrons plus 4 hydrogen substituent minus 1 for the positive charge. So this is 8 tetrahedral. So this should be sp3 hybridized. Right? That should be your answer. Moving on to the next question. The next question states that for the reaction PCl5 to PCl3 plus Cl2, the above reaction is a first order reaction, has initial moles as 10 and final moles as 2. Find the rate constant if time is 120 seconds. Okay, so for the first order reaction, rate constant is equal to 2.303 by T. log of A0 by A0 minus x. Right? So time is 120 seconds. Substitute it on your formula. And log of initial moles was 10 and final moles was 2. Log 5 value is already given to you. 2.303 into 0.693 by 120 seconds, right? So your unit should be in second inverse. Why? Because the second is in denominator. So you have to check that also in the options very clearly. So this should come out to be 2.303 into 0.693 divided by 120 would come out to be 0.013 second inverse. This should be your answer. Moving on to the next question. The valence shell electronic configuration of an element is 4s2, 4p1. The diagonally next period element in p block would be. So, the configuration given to you is 4s2, 4p1. Right? Firstly, this is the valence shell electronic configuration. Electronic configuration. Right? So what can we write the formula or the electronic configuration of the compound to be? So before this, that is the 1s2, 2s2, 2p6, 3s2, 3p6 was the configuration of which noble gas? Argon, having atomic number 18. So we could write this element, arbitrary element X is actually having argon core 4s2, 4p1 configuration. Right? Now which is it actually? It is basically which element? Gallium. It is gallium, right? So let's write it down. So the diagonally next period element in P block would be tin, Sn, which is diagonally next period element. That should be your answer. Okay, if you could identify the element X, then the thing was pretty simple. Which of the following, next question, which of the following does not have the magnetic moment of 1.73 Bohr magneton? Just you have to find out the number of unpaired electrons. If you can do that, then the question is as simple as it can be. Okay, so let us do for the coordination complex first, which is option number C. Copper NH3 whole 4 Cl2 complex. This is -2. The coordination sphere should have a charge of +2. Ammonia has 0 charge, so copper is +2 here. +2 meaning argon core 3d9. Right? 3d9 means this is a tetrahedral complex. So Eg is below and T2G is above. So this should be 1, 2, 3, 4, 5, 6, 7, 8, 9. One unpaired electron, right? So if you put it in the value of magnetic moment, this should come out to be 1.73. Why? Because whatever value is given to you, consider the number before the decimal point, and that is actually your number of unpaired electrons. It's just a small trick that whenever you're calculating the magnetic moment and the value is given to you, the number before the decimal point is actually your number of unpaired electrons. So since it is 1 and you have 1 unpaired electron, so definitely copper 2 plus will give you this value, 1.73 Bohr magneton. The next one let us do is for cupric iodide. So this should be -1 plus 1. So cuprous iodide. So this should be +1. +1 meaning argon core 3d10. No unpaired electrons, so magnetic moment is 0. Right? Next, let us do for O2 minus. O2 minus meaning 17 electronic system. Okay. Another thing, it is greater than 14 electrons. So there is a diagram which I can show it to you. Or it is simpler to understand that whenever the number of electrons, so the total number of electrons is greater than 14, your MOT diagram should come out to be like this. 1s, sigma 1s, sigma star 1s. I'm not drawing the energy pattern diagram. I'm just showing the levels. Sigma 2s, sigma star 2s. Whenever the number of electrons is greater than 14, the sigma 2pz comes below. Whenever the number of electrons is below, above 14. Then pi 2px, pi 2py, pi star, the antibonding orbitals, 2px and 2py, and sigma star 2pz. Right? Now fill up 17 electrons, 2, 4, 6, 8, 10, 11, 12, 13, 14, 15, 16, 17. Number of unpaired electrons, 1. Definitely it should have that value of 1.73 Bohr magneton. Coming to O2 plus. O2 plus meaning option A is O2 plus. 15 electrons, again greater than 14. So this should be the diagram. But what change? Only the change in the number of electrons. So this up till here, 2, 4, 6, 8, 10. Fine. 11, 12, 13, 14 and 15. Right. So this will also have O2 plus will also have a magnetic moment of 1.73. So your answer would be option number D, that it does not have 1.73 Bohr magneton answer as the magnetic moment because it has 0 unpaired electrons. You could have done it in the second step only when you found out copper iodide, but I did all the options so that it's clear to you how you find it out. Alright. The next question says, in nitration, both HNO3 and H2SO4 acts, right? So, how will we know that what does it act as? For that, you need to know the mechanism. That is important. If the mechanism is not known, then there is no point doing the question, right? So, first let us understand that when both the acids are given, see, both cannot act as acids, right? So, what can we do? Nitric acid has a structure like that. HNO3. Okay, this is the structure of nitric acid. What it does is, nitration means addition of NO2 group, right? So the first step, what it does, it abstracts a proton. Now question is, where will it get the proton from? From the sulfuric acid. It abstracts one proton and this bond opens. Okay. So what happens? What do you get? Forget about the sulfuric acid part. So since the sulfuric acid is giving a proton, so this will behave as an acid. Right? Now, what happens to the nitric acid now? N double bond OH2 plus. Water is a good leaving group. Right? It can leave very easily. So how will it leave? This negative charge goes into resonance and this is lost. So what is the electrophile that you're generating, which is actually the main reacting species? The electrophile we are generating is, one second, I think I have forgotten to put a plus charge. Yes, there will be a plus here. Okay, on the nitrogen. So the electrophile we are generating is this. Right? Now suppose we have benzene and we want to react the electrophile. Which should be the case, right? Nitration means addition of NO2 group. Correct? So what will happen? Here, attack, bond opens. So what will we get? NO2. I mean, if you want to draw it, this should be one like this and one should be minus, O minus. And there should be an H, then resonance. What do we get? NO2. This is the mechanism. So, in order to form this NO2 electrophile, what are we doing? We are abstracting a proton. So, which substances abstract a proton when they are bases? So, here nitric acid acts as a base and sulfuric acid acts as an acid in this particular system. Now, the next question says that 50% of the tetrahedral voids in a 50% of the tetrahedral voids and of FCC lattice is filled, find the effective number of atoms if made using same atoms. The question is very simple. If you know the basic of solid state, this should be done. So, number of tetrahedral voids is equal to twice the number of atoms due to FCC. So, the number of atoms due to FCC is what? 4. Why? Because atoms are present in the corners, because of which the contribution becomes 8 into 1 by 8, which is equal to 1. And on the faces, which is equal to 6 into half, which is 3. So, total of 4 atoms. So, 4 into 2, 8. Now, the question says, find the effective number of atoms in the cell. So, first things first, you have to keep these numbers fixed. So, actually the cell is what? It is an FCC cell plus tetrahedral void atoms. Atoms, right? Clear? Right? But the question says that there is only 50% tetrahedral void. So how much of 50% or half of 8 would be 4? So now tetrahedral void atoms is 4 and FCC total atoms is 4. So so the effective number of atoms would be 8. This was what was required. It is very simple, very flat question. Alright? And the last question for today's video will be, that is also a very simple question, children. It is the basics of mole concept. So the question says, an equimolar mixture of NaOH and Na2CO3 weighs 4 gram, then the weight of NaOH is. So equimolar means the number of moles is the same, right? So if I have, so NaOH and Na2CO3, the moles are same. That is what is told to you. So suppose there are n moles of NaOH, so there will be n moles of Na2CO3 as well. Another thing that is mentioned to you is the weight of NaOH and the weight of Na2CO3 equal to 4 gram. So if I consider, let us consider the weight of NaOH equal to X gram. Then therefore Na2CO3 mass would be, or weight would be 4 minus X gram. Just this much was needed. Now number of moles of NaOH means given weight X gram by molecular weight of NaOH, which is 40 gram. This is equal, this is number of moles, so it should be equal to number of moles of Na2CO3, where the given weight is 4 minus X gram and the mass would be 46 plus 12 plus 48, 106 gram. Just find out X from here. So 106 X equal to 160 minus 40X. Correct? So this should be coming out to be 146X equal to 160. So X would be 160 by 146. That comes out to be 1.09 gram. Now this was only asked because the mass of NaOH was asked and we had fixed X as NaOH. So this should be our answer. So I have done the solutions of the questions which have come from the physical and the inorganic portion, some of the questions. The organic portion questions will also be uploaded for you. So just match your answers. And I hope most of the answers were correct for all of you. And you've got that confidence. Hoping to see you fly with great colors. And I hope that all your exams will be really good. And you will come out with great ranks. Keep watching and we will be uploading the organic chemistry solutions very soon. One more thing, if you have any questions regarding any of the answers which I have solved or any other procedure you have solved it with, please let me know in the comment section below. Till then, take care. Bye-bye.